I want to talk about the unfolding argument. It's been put forward by Döring and colleagues, and it is about how do we define and identify consciousness. For example, if you have an animal or a robot, how do you know whether this entity is conscious or not? So the background is we want to define consciousness in terms of empirical research. So it's not about metaphysics, about something that we could in principle never observe. It's about what observable pattern in the world do we identify as being conscious. And there is one strain of theories that has been put forward and says that for consciousness, you need a neural network to have recurrent connections. So let me explain a bit where this is motivated. So the rise of machine learning has put forward artificial neural networks that try to simulate in the spirit of the brain what the processes in humans are and try to bring it into a computer. So what you usually find in so-called artificial neural networks is a layer of artificial neurons, which are just like similar to like real neurons in your brain that fire onto a next layer of neurons. So they are connected like synapses and neurons are connected in your brain, in a human brain. And so they basically have a first layer that is kind of similar to our retina. You show a picture to a human, or in these artificial neural networks, you basically just put the values of an image onto the first layer, and then from your retina, the activation of your cells there is feed forward to the next level, which is basically in your head in the back of your brain, and then is put forward layer by layer until it reaches the frontal lobe. And in artificial neural networks, you have the same structure. You have layer by layer, and activation is put forward until in some final layer you have a classification. So for example, you put into the neural network different pictures of animals, and the network tries to identify which animal it actually is. So these artificial neural networks, as they are used right now in image classification, they usually have a feed-forward structure, meaning that activation only flows in one direction. But we know in the human brain, there are also feedback connections, like connections that go back. For example, if in my human brain I see a cat, this concept is activated, and that concept tries to verify itself, putting back activations, basically asking, okay, I think I see a cat, is the leg there, are there 4 legs, are there 2 eyes, and so on, and trying to verify this concept. And then there's this kind of like dynamic where your brain tries to establish, yes, there is really a cat. And then in an artificial neural network, it's just this one way. You see some pixels, combine them, and then you say, the computer says it's a cat. All right. And so we would not usually say that artificial neural network simulated on a computer is conscious of the picture, but we would say that if I look at a picture of a cat, that I am conscious of this. And that's where these theories kick in and say, well, your consciousness comes from this recurrency. Okay, and now the argument, the unfolding argument, basically says that these theories have a serious problem, that they are basically wrong, or at least not scientific, which is kind of like the biggest insult you can make that to someone in science, to say that you are not scientific. And they say the following thing. The unfolding argument goes like this. So we know from computer science that when you build an artificial neural network, like this, and we can actually build artificial neural networks with recurrencies, right? So if you can build an artificial neural network that has these recurrent connections, you can build an equivalent neural network that's maybe a bit bigger, like has more layers or so, that produces the same input-output behavior. Like if you put in a certain image to the recurrent neural network here on the left side, and this puts out some activation or some classification, says, okay, this image I think is a cat and this image I think is a dog. you can build an equivalent network that only has feed-forward connections that has the same input-output behavior. And therefore, since we are doing science, since we are like observing this input-output behavior, and that's the only thing that we as scientists are interested in, like observable behavior, since we are only looking at this, and the underlying structure, whether it's recurrent or feed-forward, we cannot distinguish from the behavior, from the pattern of behavior, what the underlying structure is, because both structures can fulfill the same behavioral patterns, the same input-output relations. And therefore, it's basically just speculation or metaphysics to think about whether the underlying structure is recurrent or feed-forward, and therefore it's just metaphysics whether the underlying system is conscious or not, right? Because according to these recurrency theories, the one would be conscious and the other one would not. And the unfolding argument is that since you can implement every input-output behavior pattern with both structures, you can never know which structure it is, and therefore you can never know whether it's conscious or not, according to these structural theories. And therefore the structural theories are crap, because you cannot make a distinction based on that. So you should discard all theories about this recurrency stuff. Okay, because, and just to say this one more time, because the same input-output pattern can be fulfilled by both structures. And now, I have a problem with this argument, that's why I talk about this, and let me make an example. Let us discuss the difference between teleportation and walking to a place. So, I would argue it's a similar situation. You have a kind of input-output behavior. You start at one location and you end up in another location. And something happens in between, and this can either be walking or teleportation, right? Two things, two internal things that produce the same effect. And let's assume that every input-output is exactly the same. For example, that when you teleport, you use up exactly as much energy as you would use up by walking. The only thing is that in the way between, you would just not be there, right? You would just jump kind of into, in physical terms. I don't know how to exactly to describe this, but you would teleport. There would be a distinguishable difference if you look at the process itself, just as there is a distinguishable difference between feed-forward and recurrency. And now the unfolding argument, applied with the same logic, would say here, well, you can never distinguish between teleportation and walking because the input-output behavior, the observable behavior, is the same. You get from one place to another. And now I think my example makes it obvious that there is a problem here. And the problem is, yes, of course, if you treat this thing that you are looking at as a black box from which you can only get input-output behavior pattern, then you cannot distinguish between recurrency and feed-forward because both systems, both artificial network structures can fulfill the same input-output behavior pattern. But as with walking and teleportation, you can look whether someone is actually moving. And with these input-output behavioral patterns, you can not only look at this black box behavior, you can also look into the black box. You can check in the human brain whether there are recurrent connections. You can check whether they are in an artificial neural network are only feed-forward or feedback connections. So at this point, it seems quite obvious that there's a fundamental logical problem with this argument. And the counter argument from the unfolding argument paper, so what they would reply to this problem that I just talked to you about, is, well, if you now look into the black box and you identify something as being conscious only or just because it is recurrent, then you are kind of tautological, because of course we can call something that is recurrent conscious and something that's not recurrent unconscious, but where's the value of the concept unconscious or conscious if it just is exactly a system being recurrent or feed forward, right? So it's kind of like nonsensical to attribute then an additional label to something that is recurrent. We know it's recurrent. Why should we call it now conscious? So it would be stupid to give this additional label. And I would argue, well, actually, that happens a lot. I think a lot of terms that we come up with are just basically combinations of different other terms. Like a new word that, or maybe not a new word, but a definition of a word is just an association of different other words. And so these causal theories that say that consciousness is recurrency not only talk about recurrency, but have some other properties of a system as well. Like you have to have recurrencies, but you have to have them in a certain constellation. There's, for example, this integrated information theory by Tononi, which says that you can compute how much information a system has given that there is some specific recurrency. And from this exact pattern, you can compute how much information there is, how much conscious content there is. And that's what you can go for. You can say, we define this concept in these terms. I'm not saying that you should, and I'm not saying that this is the only sensible way to define consciousness. I'm just saying that the unfolding argument doesn't really make sense to me. So you cannot reject theories on consciousness that say recurrency is required for consciousness and feed-forward can never be conscious. You cannot discard these theories just because a recurrent neural network can be simulated by a feed-forward neural network. Yes, of course they can be. They can fulfill the same input-output behavior, but conceptually it's still different, and it is something empirical, so it is still scientific. You can look into the black box, you can identify which one it is, and then you can say, well, I consider this, given these and these other circumstances, as conscious or not. Yeah. That's all I got to say about that, and have a good night.